Hey everybody, so for the last topic of this chapter, we're going to talk about properties of trapezoids. So this is going to be a pretty quick video. I'm just going to go through two special properties that trapezoids have. So first off, a trapezoid, what is it? A trapezoid is a quadrilateral with exactly one pair of parallel sides, whereas when we talked about the parallelogram had two pairs of parallel sides. So the properties for a trapezoid are a little bit different. So the parts of a trapezoid, they have two bases. The bases are the two sides that are parallel to each other. That's what we call them. And then the other sides are called the legs. Those are the two non-parallel sides. Then we use the word base angles. There's two pairs of base angles. The base angles are the angles that are formed by the legs. So this parallel line has two base angles, and then the other parallel line has two base angles. Okay, so then there's a special type of trapezoid, which is the isosceles trapezoid. Now this one has a couple of special properties that we'll talk about. So an isosceles trapezoid is a trapezoid with congruent legs. So in this trapezoid, BC and AD are the bases, and then AB and CD are the legs. Since it's isosceles, those two legs are congruent to each other. Okay, so the special properties that an isosceles trapezoid has is the first one, the base angles are congruent. So I'm going to put the pairs of base angles are congruent. And this is only true if it's an isosceles trapezoid. So the pairs of base angles are angle A and D. So angle A and angle D are one pair of base angles, so they're congruent. So angle A is congruent to angle D. And the other pair of base angles would be angle B and angle C. So angle B would be congruent to angle C, only when it's an isosceles trapezoid. Okay, the other property of isosceles trapezoids has to do with the diagonals, and that is that the diagonals are congruent. Okay, so diagonals are only congruent in isosceles trapezoids. So the example here, the diagonals would be diagonal AC is congruent to the other diagonal, BD. So their lengths are exactly the same. All right, now the next word that we're going to discuss as far as trapezoids go is the word mid-segment. So I have all these notes, so if you want to write them down, you can pause it. I'll also post these notes as well. So a mid-segment of a trapezoid. We've talked about the word mid-segment before in reference to triangles. A mid-segment connects the two midpoints of the sides. So the same thing works with a trapezoid. A mid-segment of a trapezoid is the segment whose endpoints are the midpoints of the legs. So here's the definition. The midpoints of the legs. If you connect the midpoints of the legs, it's called the mid-segment of the trapezoid. Now, when you draw in the mid-segment, just like in a triangle, the mid-segment of a trapezoid is parallel to each base. So we know that the two bases are parallel to each other, and then the mid-segment of the trapezoid is also parallel to those bases. So we have a whole bunch of corresponding angles, a whole bunch of consecutive interior angles, and then also the mid-segment's length is, oh, I spelled that wrong, it's 1/2 the sum of the lengths of the bases. Okay, so the formula for that is right here. The mid-segment's length, so in this picture that I drew, xy is the mid-segment. The length of that mid-segment is 1/2 of the sum of the bases. The bases are AD, which is the bottom, and BC, which is the top. So if you add the bottom and the top, the two parallel lines, if you add them together and you cut it in half, you'll get the length of the midsegment, which is pretty similar to the triangle midsegment theorem, but the midsegment of a triangle was only parallel to the one side, so the midsegment was half of that side. In this case, there's two bases that it's parallel to, so you need to add them together and then divide it by 2. So that's how we find that. I wrote the word or here because there's also another way we can rewrite this formula here, which I prefer. Instead of saying that the midsegment is 1/2 of the sum of the bases, if I multiply this side by 2, that 1/2 goes away, but then I also have to multiply this side by 2. So the formula that you end up getting is 2 times the midsegment, so 2 times xy equals AD plus BC. So the midsegment times 2 is equal to the sum of the bases. They're the exact same formula. I just manipulated a little bit with algebra. Okay. I'm just going to make some markings on this picture as well. Just as a reminder, whenever you have parallel lines, the corresponding angles are congruent. So in this case, angle A corresponds to angle BXY, so those are congruent to each other. Angle B is corresponding with angle AXY, so those two are congruent. And then on the other side, angle C, I'm going to put 3 arc marks, corresponds with angle DYX. So I'm going to put 3 arc marks there. And then lastly, angle D, it's kind of be hard there. I have to put 4 arc marks, but angle D, I'm actually just going to write it. Angle D is congruent to angle CYX. Okay, because they're corresponding. And then also the consecutive interior angles are supplementary. So these two angles add up to 180, these two angles add up to 180, and so on. These two add up to 180, and these two add up to 180. And then the linear pairs, those are supplementary. And then we also have more consecutive interior angles, like angle A and B are consecutive interior, so they add up to 180. And angles C and D are consecutive interior, so they add up to 180. So all your properties of parallel lines apply. Okay, so we're just going to finish this off with 4 examples. So in example number 1, the question that I want you to answer is I want you to find the measure of angle F. Okay, so in this picture you can tell we have FE is congruent to GH, which makes it isosceles. So since it's an isosceles trapezoid, the base angles are equal. So that means angle H should be congruent to angle E. So that means angle E is also 49 degrees. Another thing is the consecutive interior angles are supplementary, which means angle E and angle F are supplementary. So we're going to do 180 minus 49, and 180 minus 49, that's going to be 131. So angle F is 131. We could have also started off by saying, well, if angle H is 49, 180 minus 49 is 131, so that would have given us angle G. And then angle G and angle F are congruent because they're base angles. So that was just one other way. So the measure of angle F is 131 degrees. Okay, in question number 2, they tell us the length of JN is 10.6 and the length of NL is 14.8. So JN is 10.6. I can actually put that in the picture. And then NL is 14.8. So they actually gave us the entire diagonal. If we add those two together, 10.6 plus 14.8, let's see what we get. We get 25.4. So the length of JL is 25.4. Now, since this picture is also isosceles, Kj is congruent to Lm, that means that it's an isosceles trapezoid, so the diagonals are congruent. So if the length of JL is 25.4, then the length of Km is also 25.4. Okay, question number 3. Looks like we have a mid-segment drawn in there. Find the length of ST. So they give us the length of the mid-segment is 31. They give us the length of one of the bases is 38. They want the length of the other base. So we're going to use our formula. So we can either do formula 1, which was xy equals 1/2 times AD plus BC. So that would be 31 equals 1/2 times, I guess we can call this x plus 38. Or we could do 2 times mn equals x plus 38. In this case, I'm going to use the 2 times 31 because that way we don't have to deal with that 1/2. So I'm going to do 2 times 31 equals x plus 38. If you want to do it the other way and distribute that 1/2 into the parentheses, that's an option. But I think it's a little bit easier to do it this way. 2 times 31 is 62. So 62 equals x plus 38. Then to find what x is, we're going to do 62 minus 38, and you get 24. So x is 24, so that means the length of ST is 24. All right, and then one last question, looks like another mid-segment question. They want us to find the length of xy. Looks like we have a little bit of algebra involved here. So xy is our mid-segment, and then BC and AD are our bases. So we can use two different formulas. We can either use xy equals 1/2 times AD plus BC, or we can use 2 times xy equals AD plus BC. If we do n plus 6 equals 1/2 of n plus 3 times 3n minus 5, we have to distribute that 1/2 in. We're going to distribute it to a 3. We're going to distribute it to a 5, a 3. We're going to get decimals. I'd rather that not happen. So I'm going to use the other formula, which is 2 times xy, which won't create any decimals, equals top plus bottom, base 1 plus base 2. So that's going to be 2 times parentheses n plus 6, make sure you use those parentheses, equals n plus 3 base 1 plus 3n minus 5 base 2. Okay, let's clean that up a little bit. We'll distribute on this side, then we'll combine like terms on this side. So when we distribute, we end up getting 2n plus 12 equals, and then on the right side, combine like terms, we get 4n, and that would be minus 2. To solve this equation, subtract 2n from both sides, and then add 2 to both sides, and you'll end up getting 2n equals 14, and then divide both sides by 2, and you get n is 7. Now they want the length of xy, so our last step to find xy, we're just going to plug it in. That's going to be 7 plus 6, and 7 plus 6 is 13. So the length of xy is 13. Okay, so those are the final properties for this chapter. If you have any questions, let us know. Have a good day.